Hey everyone, it's James from Zygal Studios, and I'm back again with another programming lesson. This is going to be the fourth lesson in the C programming series on conditional statements and making decisions. Okay, let's start with going over the homework from the last lesson before we get into conditionals. So the last lesson we talked about for loops and looping in general. Well, we had to create a 15 factorial function that would produce the factorial of 15 and then print it. This is one possible solution, and it is probably one of the quickest that you can find. Apart from doing some bit operations, of course, which would be kind of gross. So using loops, this is about as quick as it gets. So we have an unsigned long factorial. Since 15 factorial is a very large number, you might have run into an issue where if you use just an int, it might not have been big enough, and that can be a major problem because 15 factorial is 1 point something times 10 to the 12. Int only goes up to 2.1 billion, so that means that, first of all, you need unsigned. So that means a long data type should do just fine. That goes way above that, and it can fit the factorial of 15 in its scope, no problem. So that's the first step. Second step is 15 factorial is 15 times 14 times 13 all the way down to times 1, okay? So instead of counting up like how we did in the assignment, I wanted you guys to experiment with counting down. So counting down, we start at 15 while I is greater than 0, so it'll iterate 15 times, and subtract 1 from I every time we go down. And then all we do is we use this factorial function, which has to be 1, by the way, because otherwise it would be 0 if you initialized it to 0. Multiply the index, which just loops down to 0. Loops down to 1. So it's basically 15 all the way down. Now, if you wanted to be even more clever, you could do this, because it's the same answer. 1 times the whole product is going to be 1 still. So this will actually be a little bit quicker. So this will print the index at each one, and then it'll print the final result. So let's double check our math here. So let's get the calculator up. All right, so we want to compile our homework. I didn't give it an output name. That's kind of concerning. Okay, so homework 3. That is our answer, and let's take a look here. So 15 factorial. It looks like we're right on the money. So these two numbers match. All right, so if that is the case, now let's move on to conditionals. All right, so making decisions. This is probably the most quintessential part of programming, and it makes your life as a programmer a heck of a lot easier. In order to make decisions inside of the C programming language, you really have 3 options. The first are if and else statements. The second are switch statements, and the third are ternary statements, but they're really the same as if else, just in a different way. So let's go over, we talked about operators before. Let's go over some new operators that go inside of if statements. So the logical operators are the first. So these are basically digital logic operation, like logic gates. If you don't know what those are, I'd suggest you pause the video right now and go learn about logic gates. I'll link something in the description below so you can learn about that a little bit. So logical operators. So this is a logical AND. It has to be a double ampersand. It can't be 1. If it's 1, it will just AND the result with it, and it will always be true. That is something to watch out for. Do not, I repeat, do not only use one of each of these, because one of each of these logical operators, if you use one of those, it will always return true. Okay, I'll get to that in a second. If you want to see if 2 things equal the same thing, the logical AND will be the use case for that. If you want to see if something is one or the other, so let's say there's 2 conditions, you have one, it can be one or the other. It doesn't have to be both, but it can be true for one of the 2. The OR operator is what you want. If you want something to not be equal, or something that's the inverse of, the not is exactly what you'd want to use. So, for example, if something is not equal, so let's say x, if x does not equal 5, In code, it looks like this. That's where you would use a not. You can use it with other operators too, but this is probably the best practice. I would avoid using it elsewhere. All right, relational operators. This is where you get all your decision making from. So you can have equal to, which is a double equal sign. Once again, do not put an assignment statement inside of an if inside of the scope of an if statement, because it will always return true. Assignments can happen regardless. C allows you to do this. This is a problem. Do not use just one. Greater than, so you can check to see if numbers are greater than or less than from each other. Both of these are pretty obvious. Not equal to, like I said up top, that's where the logical not comes in. Not equal to 5. Greater than or equal to, this is, once again, you have to be careful. You have to treat it as if it's like how for loops are, where you go to a number and then to the equals of a number. Be careful about that. And then less than or equal to. This is elementary algebra all over again. All these greater than, less than, all this fun stuff. Okay, let's hop into some examples. So let's talk about the if construct first. So let's say I have two variables, x, which equals 2, and y, which equals 22. So let's talk about the if statement. So if, in C, if statements are done like this. You have the if keyword, a scope, which is delimited by two parentheses, open and closed, the brackets, which then determine scope, which is once again the same thing as the for loop. So if y is greater than x, which it is, this should print y is greater than x. So if we compile this guy, actually I think I already have it compiled, but let's try it anyway. The first argument here, y is greater than x, it prints that. Okay? So I hope you're starting to see how this can really help you out. You're basically checking to see if something is different than something else. And that's really where decision making comes in. But what happens if I have something that I'm looking for, like if y is greater than x, but what if x is greater than y, or there's some other condition where y equals x, or y doesn't equal x? Well, that's what the if-else is for. So the if-else says, we're flipping it around now so I can trigger the else statement. If x is greater than y, so if 2 is greater than 22, we are going to print x is greater than y. If it's not, it could be anything else. It could be greater than, equal to, doesn't matter. If it's anything else than this condition here, it will trigger the else statement. So the else is done similar to the if. It has to follow an if statement. So after the bracket of an if statement, the keyword else, that is the only time you can use that statement, unless it follows what's called an else if, which I'll get to next. So you must scope your if, finish scope, and then keyword in else afterwards, and then scope whatever you want for else. Okay, so let's run that again, and let's see what it prints. It should print the exact same thing. Y is greater than x. We know that, James. But this is to prove how if-elses work. So y is greater than x. Let's move down to the else-if construct, okay? So on line 58 here, moving into 59, so we have the same syntax as we do before here. So remember, x is 2 and y is 22, okay? So if x is greater than y, which it clearly is not, we will then look at an else-if statement here. If x is equal to 2, this, once again, this is not the assignment operator that we talked about a few lessons ago. This is x equal to 2? If it is, we want to print x is equal to 2. Otherwise, if it's anything else, if x is not greater than y, and if x does not equal 2, the else statement will trigger. So you can probably kind of see at this point how useful this can be. And the best part about this is you can just write as many of these as you want. I'm not kidding. You can do as many of these as you want. So let's say you wanted to check to see, I don't know, if y is equal to 44, or I don't know, x doesn't equal 2, or doesn't equal 77. Okay? You can have as many of these as you want. So let me recompile and show you. it's not going to change the result, but and something important to note here. If one of these statements is triggered, none of these get looked at. So it's in order of precedence. So if x equals 2, which it does, it will not look at the rest of these else if statements or the else statement. It just simply won't. When the scope is over, it's out of that piece and into the new instruction. All right, I know I've covered a lot of material really quickly, but this is the basics of if-elses. Let's get into Booleans now, because Booleans are really important. So let's say Booleans now require us to include a new library, which is called the standard bool.h library. This was included in the C99 standard, which is generally included with most compilers now, but you must include this in your include chain. So if example equals to true, so let's start by initializing example to true. So at this point, you could either initialize it to true or false. Those are two keywords that allow assignments to this variable, to a bool variable specifically. So if example equals true, we want to print example is true. Otherwise, we want to print false. And obviously, the example is true if we've set it. Something to note here, syntax that's equivalent with this would be these two if statements are exactly the same. If this is anything other than 0 or false, this will trigger this if statement. It is the exact same thing as this, except for the fact if example for some reason is an int and it's greater than 0, it will still go into that if statement. That's something to watch out for too. All right, so when we run it, as you can see, example is true. Okay, now we're moving into the ternary statement. So a ternary statement is essentially a fast shorthand way of an if-else statement, and it's really confusing. It's very, very frowned upon by most coders in production code for specifically this reason. It's hard to figure out what's going on. But if you follow the syntax, you should at least know how this goes. So here we have an if-else statement. This is exactly the same format as we saw before. So we have A equal to 10, B equal to 20, and C uninitialized. Okay? So if A is less than B, so if 10 is less than 20, which it is, C becomes A, which is 10. Okay? So if we print that out, we should see 10, right? If else 10. Okay. Now here's the other side of it. Okay? So here's what's called a ternary operation. So C, as you can see, is assigned inside the scope of these variables. The ternary statement does this exact same thing as this specific if-else statement. So it has a condition which is delimited by the open and close parentheses, much like how if-elses are done here. Then it uses a question mark as an operator, as the ternary operator, and the first condition will be if A, else B. Okay? So this is kind of confusing, I understand, but let's walk through it step by step. So if A, which is 10, is less than B, which is 20, so in this case, if it's true, we want to assign C to A. Else, we want to assign C to B. So this is the exact same thing. So think of the if statement without the brackets. After this question mark, this goes here. And ends at the colon. After the colon, this goes here. It's confusing and it's over the top, and sometimes when you mix it with other operators, it looks ridiculously disgusting. But it does print the same thing, and I'll show you that right now. 10. Okay? All right, the last thing I'll talk about is a switch case statement. So a switch case statement is the faster operation of the two between if-else and switch case. So generally, you use a switch case when you know the exact amount of permutations that you have in a specific decision-making operation. What do I mean by that? So with an if-else statement, you can say if A is greater than B. If A goes up to 3,000 and B goes up to 2,500 or something, then inside of that entire range, all you need to do is have this assignment statement, okay? That's not the case with a switch case. With a switch case, you have to do all 3,000 and all 2,500 permutations one by one in order to get that to work the same way as an if-else statement. This is only for a finite set of things. So switch is a keyword, and it has a scope, which is a variable of some kind. Inside of the scope of the switch, we have cases. A case is a keyword inside the scope of a switch. So inside the scope of a switch, we have case, and then we have this. It must be a case. It could be an integer. It could be a character. Anything that's 1 byte long, or anything that fits into the standard operators will fit inside of a case here. After that case is done, there will be a colon to delimit the end of the line, and then after that, in between the colon and the word break, you must put break here. It will allow you to compile and run without it, but it will completely screw up the instructions. In between this colon and the word break, this is the action you want to take. So it's like if-else, only specific cases one by one. And then you must put a default case. This is no question. It's not just good practice. It's really the law in terms of programming in C if you want to be a proficient C programmer. Default is necessary. The case is if none of these are true. So let's say I'm at index 3, which I'll reach index 3 in this for loop. What do? Well, you could either do nothing or do undefined behavior if you're missing this case, or if you're missing this default case, or you can just say, hey, when it's not 1 or 2, I want to do this. So it provides a little more resolution, much like this if statement, not quite enough to cover the scope of this if we're talking in the thousands or hundreds, but it does provide some. So for case 1 and case 2, I want to print what j is inside the for loop, or I just want to print this is the default case. So what we should see on this output is this is the default case because j is 0, which is none of these. We should see j is 1, j is 2, and then finally for 3, we should see this is the default case. Let's try it out. What do you know? One last thing to mention. If statements can be done inside of each other. So if I wanted to do an if statement inside of this if statement, I could. If I wanted to do an else statement inside of this if statement, I could. Just to include that, because that's important. Okay, so for the homework this time around, I want you to use nested for loops, 2 variables, I and j. One counts up, one counts down until the decision point. Once I counts up to 500, count j down to 500 from 1,000. Once j is 500, count I down to 0. And then finally, once I is equal to 0, count j to 0. Thank you so much for stopping by and watching my programming tutorial. I really hope this is helping some of you. I love teaching this material and sharing it with the world because it's a wonderful thing and it can only make the world better. So keep that learning cap on, folks. Keep the fingers loose, and I'll see you next time for Lesson 5. Thanks. It's James from Zygal Studios, signing off. Hey everyone, it's James from Zygal Studios. So thank you for watching my tutorial on how to program in C. There's going to be more videos coming in the future, so if you could hit the subscribe button, I'd really appreciate it. I've wanted this series to take off for a while, so please, if you could, show some support and like and comment on the video if it helped you. If you guys have any suggestions for future videos, please put them in the comments below. Thanks so much, and hope to see you back here again soon.